Now, in this session, we are going to see the electromagnetic waves and few numericals. Now, what are electromagnetic waves? Let us see. Electromagnetic wave is a wave produced by mutually perpendicular oscillating electric and magnetic fields perpendicular to the direction of propagation of a wave. Electromagnetic waves are produced because of mutually perpendicular electric and magnetic fields, and direction of propagation is also perpendicular. That means if a wave is propagating in x direction, along the y direction electric field will be there, and along the z direction magnetic field will be there. And all these three, the magnetic fields, electric fields, and the direction of propagation of the wave are three mutually perpendicular to each other, and such waves are called as electromagnetic waves. Electromagnetic waves can travel anywhere in the medium, also in the vacuum, with the speed of 3 into 10 to the power of 8 meters per second. So, we know that Maxwell's equation for the time varying field are given by del dot D is equal to rho, del cross E is equal to minus dou B by dou T, and del dot B equals to 0, and del cross H is equal to J plus dou D by dou T. These are the Maxwell's equations which I have seen in the previous sessions. Now, using these equations, four Maxwell's equations, we can it has been concluded that wave equation in terms of electric field E using Maxwell's equation is given by del square E minus mu epsilon into dou square E by dou T square is equal to mu into dou J by dou T plus del into rho by epsilon naught. This is a wave equation in terms of electric field using Maxwell's equation for a homogeneous isotropic medium with mu and epsilon. But for a free space, rho equals to 0 and J equals to 0. Therefore, the wave equation for a free space is del square E minus mu E into dou square E by dou T square equals to 0. That means the left hand side of the equation only exists, right hand side goes to 0 because rho goes to 0 and J goes to 0. So, this is a wave equation for free space because electromagnetic waves can travel in the vacuum. Next is plane electromagnetic waves in the vacuum. We'll see what are the plane electromagnetic. As I said earlier, electromagnetic waves can travel in vacuum. So, the plane waves are the waves that vary only in the direction of propagation, and their characteristics remain constant across the planes normal to the direction of the propagation. That means the plane waves are the waves that vary only in one direction of propagation, and their characteristics remains constant across the planes normal to the direction of propagation. Now let us see. If a plane of electromagnetic wave of wavelength lambda propagating in a vacuum along the x-axis. That means consider a plane electromagnetic wave having a wavelength of lambda propagating in vacuum along the x-axis. As I said you, electromagnetic waves can travel in vacuum also. They don't require any medium. It can travel even in the vacuum. If Ez and Bz be the electric and magnetic fields with an amplitude A along the y-axis and z-axis respectively, and at any instant time t, and c is the velocity of the electromagnetic wave with the velocity 3 into 10 to the power of 8 meters per second. As I told you, if the direction of propagation is along the x-axis, direction of electric field is along the y-axis, and the direction of the magnetic field will be along the z-axis. If we take such type of an electromagnetic wave at any instant of time t, Ey, Ey is the vector of electric field is given by A cos of 2 pi by lambda into x minus Ct into A component of y, and Bz is equal to 1 by C into A cos of 2 pi by lambda into x minus Ct into Az. These are the electric and magnetic field components of a plane electromagnetic wave. Now, the velocity of the wave in any given medium is given by V is equal to 1 by root of mu epsilon. That means velocity of electromagnetic wave in any medium is given by V is equal to 1 by root of mu E. V is the velocity of the wave. Now, for an electromagnetic wave which is traveling in vacuum with a velocity, what is the velocity of the electromagnetic wave? C is the velocity. So V becomes C and mu becomes mu naught and epsilon becomes epsilon naught. So the above equation becomes C is equal to 1 by root of mu naught into epsilon naught. This is the electromagnetic wave equation in vacuum with the velocity C is equal to 1 by root of mu naught into epsilon naught. Now we see the transverse nature of electromagnetic waves. So electromagnetic waves are transverse in nature. Transverse means the direction of propagation is perpendicular to the direction of vibrations. So here, in order to see whether the transverse nature of light, you should have the polarization concept. What is a light? Is a transverse nature. Light is having transverse nature. Vibrations are perpendicular to the direction of propagation. So the polarization effect explains the transverse nature of electromagnetic waves. Now, in order to explain that the waves are transverse in nature, if the waves exhibit polarization, then we can conclude that the waves have transverse nature. So, in order to conclude that electromagnetic waves are transverse in nature, we have to show that electromagnetic waves get polarized. If they get polarized, that means electromagnetic waves are transverse in nature. So, here we are explaining the polarization of electromagnetic waves, which clearly says that electromagnetic waves are transverse in nature. If you look at the diagram, X is the direction of propagation. The E is having electric field is along the y-axis and magnetic field components are along the z-axis. Electromagnetic waves is said to be polarized if an electric vector E oscillates in a plane along a straight line perpendicular to the direction of propagation of the wave. As I said you, transverse nature of light are perpendicular to the direction of vibration, means it is a transverse nature of light. That means the fields are perpendicular to the direction of propagation. So if you can see that in the down figure, electric field vectors are perpendicular to the direction of propagation. Therefore, they are being polarized. Thereby, electromagnetic waves are transverse in nature. Now, there are three types of polarizations. One is linear polarization, the other is circular polarization, and the third one is elliptical polarization. So, there are three types of polarization. One is linear polarization, secondary circular polarization, and elliptical polarization. Now we will see what is linear polarization of electromagnetic waves. When an EM wave is said to be linearly polarized if EX and EY components must be in a plane in phase and their amplitudes may or may not be equal. What is EX and EY? They are the amplitudes. The components must be in phase and their amplitudes may or may not be equal. That means for a linearly polarization of EM waves, the phase should be 0. Their amplitudes may or may not be 0. If E1 and E2 are the amplitudes of EX and EY, then for linear polarization, phase difference delta equals to 0 and EX by EY is equal to E1 by E2. If the phase difference is 0, if you look at the figure over here, if EX is equal to EY, or may not be equal, but the phase difference between EX and EY delta must be 0. Then what will happen? It will trace a path of a line. Thus the tip of a vector E traces a straight line. Therefore, it is called as a linear polarization. So, in a linear polarization, what is the condition is the phase difference delta is 0 and the amplitudes of EX and EY may or may not be 0. Sorry, may or may not be equal. Therefore, E1 and E2, if the ratio of E1 and E2 is equal to EX by EY, the phase difference delta goes to 0 and thus the tip of the vector E traces a straight line. Next, we will see the circular polarization of EM waves. EM wave is said to be circularly polarized if EX and EY components must have the same amplitude and the phase difference of 90. If the phase difference delta equals to 90 and the amplitudes E1 is equal to E2, then it will frame a circular path. So you get a circle equation EX square plus EY square is equal to E1 square. Thus the tip of a vector E traces a circle. Therefore it is called as a circular polarization. Similarly, we see the elliptical polarization of EM waves. An EM wave is said to be elliptically polarized if EX and EY components must have unequal amplitudes and the phase difference must not be equal. 0. That means the phase difference between Ex and Ey must not be equal to 0, and also their amplitudes Ex should not be equal to Ey. If we suppose that delta is not equal to 0, means if we assume that delta is equal to pi by 2, then Ex by E1 square plus Ey by E2 whole square is equal to 1, which is the equation of an ellipse. So thus the tip of a vector E traces an ellipse. You can look at the figure. If Ex is not equal to Ey and delta is not equal to 0, but delta we have taken as pi by 2, thus the tip of a vector E traces an ellipse. So this is called as elliptical polarization of EM waves. Next we will see the numerical in a EM theory. Find the divergence of a vector field A given by A is equal to 6x square into Ax plus 3y square into Ay cap plus xyz cube into Az cap at a point of 1, 3, 6. That means a given vector is A is equal to 6x square into unit vector Ax plus 3x square into Ay cap plus xyz cube into Az cap. So generally expression is given by A is equal to Ax into Ax unit vector Ax cap plus Ay into Ay unit vector plus Az into Az unit vector. That means these are the three components along x, y and z axis of a. Now what is, if you compare both the equations, if you assume that Ax, the component of x, A along x is 6x square. Comparing these two equations, Ax is 6x square and Ay is 3xy square and Az is xyz cube. Then the respective partial derivatives are, if you differentiate dou Ax by dou x, it is 6 2 is 12x, and dou Ay by dou y is equal to 6xy, and dou Ay by dou z becomes 3xyz square. So now substituting that into this equation, del dot A is equal to dou Ax by dou x plus dou Ay by dou y plus dou Az by dou z. Substituting that values into this equation, you are getting del dot A is equal to 12x plus 6xy plus 3xyz square. So this is the del dot A point, we have got it. Now we have to see that at a point P, as per the data, x is equal to 1, y is equal to 3 and z is equal to c, which is given at a point P. So substitute the values of x, y and z. Div A is given by 12 into 1, x value is 1, 12 into 1 plus 6 into 1 into 3, because x value is 1, y value is 3, 6xy plus 3, x is 1, y is 3, z is 6, so 6 square. So if you take it and do the calculations, you will be getting div A is equal to 354. This is the solution for this problem. Next we see, determine the constant c such that the vector A is equal to x plus ay into ax component plus y plus bz into a cap y plus x plus cz into az cap is a solenoidal. What is meant by solenoidal? Solenoidal means del dot A goes to 0. We are given a vector A is equal to x plus ay into a cap x plus y plus bz into ay cap plus x plus cz into az cap. So this is the equation which has been given, vector given. But for a solenoidal condition, del dot A goes to 0. Therefore, what is the value of a vector? How a vector is given? A is equal to ax into ax cap plus ay into ay cap plus az into az cap, where ax, ay, az are the unit vectors. So what is ax component here? If you compare both the equations of A, general equation, and the given equation, ax is x plus ay and ay is y plus bz and az is x plus cz. So making the del dot A, div A is equal to dou ax by dou x plus dou ay by dou y plus dou az by dou z. Substituting the values into that equation and partial differentiator, you are getting dou by dou x of x plus ay, dou by dou y of y plus bz plus dou by dou z of x plus cz. Now if you do the partial differentiation, you will be getting dou x by dou x goes to 1 plus c. For A to be solenoidal, del dot A goes to 0. That means 1 plus c goes to 0. That is 2 plus c goes to 0. That implies c is equal to -2. This is the solution for this problem. Thank you.